Hey everybody, Mr. Bress here, and I wanted to record a quick video about that osmosis worksheet for the graphing unit. And yeah, so today in class we talked about osmosis. This is a special case of diffusion of water through a membrane or a barrier that only allows certain molecules to move through. So we called that a selectively permeable membrane, or sometimes called a semi-permeable membrane. So we went over that, and there's some videos that go over that as well. And here I just want to go over the worksheet. So hop over to my iPad so I can see where we find this worksheet, and then go over a little explanation, and then I'll go through each one of the problems in there so that you can compare your answers to my answers. So let's start at Canvas here. Open it up. And depending on the class that you're in, there's both the same, but we'll go to breast biology modules here. And today was Tuesday, December 15th. So I click on there. And then we did this graphing unit osmosis practice. So I'll open that up and go up to here to send it over to Notability. I, again, have to do it kind of the slow way. You might have an option to copy it directly to Notability. If you do, go ahead and use that. And here we go. And now I'll hop back over to Notability. And I've opened this up a couple times, so I want to make sure I get the correct one opened up for you all. Okay, so let's start off here. So this is about osmosis, and we talked about this in class, and there's a picture here that shows water moving from low sugar concentration to higher concentration, and this movement of water is osmosis. And we talked about it in class, but here's a written description and 4 videos that you can watch that explain it in 4 different ways, this process of osmosis. And we talked about our short vocabulary list of words that we're going to be using, and we'll just kind of define them as we use them here. But these are words that you should be familiar with. And here we saw was an example from the video that we started this whole unit with. And here is an egg with the sugar, proteins, salt, other electrolytes dissolved in it, in a solution of just water. So there is, and what they're not showing here, which is a little not exactly accurate, is there is water in here in this egg, but there's way more water out here. And it's not way more as far as total volume, but the concentration, there's no solute out here. This is 100% H2O. And this might only be 70% H2O in here. In this case, water wants to even itself out, wants to even out its concentration. So water is going to move into the egg here. And we talked about the water can move through this membrane because sugar, protein, and other salts cannot move through this membrane. They're not allowed. The membrane is, they're either too charged or too big. They can't move out. So only water can move in between. And so water moves in here, and we call this solution with low salt concentration, low dissolved stuff, we call this solution hypotonic. Hypo meaning low, and tonic referring to the dissolved stuff in there. So this is really low. In fact, it's no dissolved stuff. In contrast, when you take the egg out of vinegar, right, it's dissolved the shell. And traditionally, when this experiment was done, you could put it into corn syrup. And now corn syrup is like approximately 75% sugar, which means it's only about 25% water. Inside the egg is maybe 30% solute. And I say solute because I mean sugar, protein, electrolyte, salt. I mean everything that's dissolved. And approximately 70% H2O. So now this solution has a much higher dissolved concentration of stuff outside. It's got a high concentration of dissolved sugar. And this makes this solution out here now is called hypertonic. Hyper meaning more, like hyperactive, you're more active. So this is more dissolved stuff. So this means water will leave this egg and try to dilute the sugar on the outside. So these little molecules here represent water, okay? And we saw this with red blood cells here. And if the red blood cells are in a highly concentrated salt solution where there's a lot of dissolved stuff and water is leaving these red blood cells, this solution, we're referring to this solution, is hypertonic. The opposite of it is if we just dropped these cells in just water, if you took out collected red blood cells and put them in water, they will fill up with water and explode. So water is going into these cells. That means this solution out here, this solution is hypotonic. There's low dissolved stuff. So there's way more dissolved things inside the cells because there's protein and sugar and DNA and RNA and all kinds of dissolved stuff inside of a cell. And if you plop those cells in water, the water is hypotonic, low solute. And so water is now going to try to go into these cells, which we saw here. If you put these cells in a solution that's balanced, that has just as much stuff dissolved inside as outside, we call that an isotonic solution. Okay. And now we had a little bit of practice here. So 10% solute inside, 15% outside. So this solution is hypertonic. And remember, this is referring to this solution. Hyper, more solute. So in this case, water is going to leave this egg. In this one, we have 10% solute versus 60% inside the egg. So this is hypotonic, again, lower solute. And in this case, water, H2O, is going to be flowing in. Another way to think about this is the solute plus the water has to equal 100%, right? So 90% plus 10% is 100%, just like 40% plus 60% is 100%. And you could think here we have high water versus low water. So you could think of water kind of flowing downhill from high to low. All right. So in this one here, this next one, 25% solute versus 20, once again, we have a hypotonic solution and water will be moving inside. So one teacher says hypo might explode. So you could think of hypo, if you put an egg in a hypotonic solution, the egg might blow up and explode. Here, 25% versus 55. Again, this is hypotonic. And our water is high here, low here. So you can imagine water flowing from high to low. This one, 10% versus 37%. This is a hypertonic solution. And in this case, water is going to flow out from the high water to the low water. And finally, in this case, we have 50 and 50. This is isotonic. And the same amount of water that goes out will come in. It's balanced. The egg should not change. Its circumference should not change at all. It's not going to get bigger. It's not going to get smaller. It's going to stay nice and the same. Okay. So this next one is basically the same thing. You just have to calculate the percent of water. You actually don't even have to do that to be able to answer the question. So in this case, it's 10% solute, so that's 90% water. And here it's 20% solute, so that's 80% water. But we already know that the solute concentration is higher outside than inside. So this is a hypertonic solution, referring to this. So water is going to come out of this. Let's do this one with 30% solute outside, 40% inside. So this is lower outside, so we call that hypotonic. And we would expect in a hypo water to flow into the egg. Now, does that make sense? Well, let's see. 30% solute, so must be 70% water. 40% solute inside the egg, so that must be 60% water. So once again, water flows from high to low, from 70 to 60. In this one, I would say, oh, water is 80% outside, 75% inside. Water flows from high to low. So I'm thinking water is going to flow into this egg. So if water's flowing in, this solution must be hypotonic. And let's check. Well, 80% water outside, so that must be 20% solute. 75% water inside, so that must be 25% solute. So yep, this is lower solute outside, so hypo, lower, hypotonic. And finally, we have a couple beakers here with an egg, 10% salt egg inside, 10% salt outside. This is just as much as leaving as would be coming in. We call that isotonic. Here we have a pretty low 2% outside versus our 10% inside. So this is going to be hypotonic. So I would expect water to flow in, but we can test this. Well, 10% salt means that this is going to be 90% H2O, 2% salt in the solution, 2%, I was excited about that. 98% water. So 98 versus 90, water flows from high to low, 98 to 90. And what do you think this one's going to be? Well, we have a high salt concentration outside. So this is hypertonic. Water is going to be flowing out of this. And now we can see, does that make sense again? Well, this is 90% H2O. This is 70% H2O, right? Because 30% salt plus 70% water give us our 100%. And once again, water flows from 90 to 70, from high to low. So These show the three, right here, 1, 2, 3 types of osmosis questions that you're going to see on the test, and that one of the physical properties of nature that we wanted to learn about in this unit. So that's it. I will see you all next time. Good luck with your studying, and be well.